Forensic chemistry is the application of chemistry and its subfield forensic toxicology in a legal setting. It's a branch of chemistry that involves using chemical concepts to solve crimes. Forensic chemists assist in the identification of unknown materials found at a crime scene. They use a wide array of methods and instruments to help identify unknown substances. This field also involves the analysis of any non-biological materials found at a crime scene to figure out how they connect to the person who committed the crime. Forensic chemistry can provide molecular explanations for evidences, which can be crucial in answering questions of interest to the legal system. It's a fascinating field that combines science and law enforcement to help solve crimes and bring justice.
Forensic chemistry. There are several basic principles that guide the analysis and interpretation of the evidence. Here are some of the key principles. Lockhart exchange principle. This principle states that whenever two objects come into contact, there is an exchange of material between them. In the context of forensic chemistry, this principle is used to explain how trace evidence, such as fiber, hairs, or DNA, can be transferred between a suspect and the crime scene. Chain of custody. This principle refers to the documentation and tracking of evidence from the moment it is collected until it presented in the court. It ensures that the integrity of the evidence is maintained and that it can be tracked back to its source, establishing its admissibility as evidence. Number 3. Preservation of evidence. Proper preservation of evidence is crucial in forensic chemistry. It's involved preventing contamination, degradation, or loss of evidence. During collection, storage, and analysis, this includes using appropriate packaging, sealing, and labeling techniques to maintain the integrity of the evidence. 4. Analytical technique. Forensic chemistry use a variety of analytical techniques to analyze evidence. These techniques include spectroscopy, chromatography, mass spectrometry, microscopy, and DNA analysis. Each technique has its own strength and limitation, and the choice of technique depends on the nature of the evidence and the information required. 5. Quality control and quality assurance. Forensic chemistry laboratories follow strict quality control and quality assurance protocol to ensure the accuracy and reliability of their analysis. This includes using validated methods, maintaining proper calibration of instruments, conducting propensity testing, and implementing quality management system. Number 6. Interpretation of result. Interpreting the result of the forensic chemistry analysis requires expertise and knowledge of the limitation of the technique used. Forensic chemists must consider factors such as the presence of the background substance, the possible of contamination, and the statistical significance of the result. This principle from the foundation of the forensic chemistry and guide the analysis and interpretation of evidence in criminal investigation.
Scientific evidence plays a crucial role in various fields, including criminal investigations, civil litigation, and scientific research. Here are some applications of scientific evidence. Number 1. Criminal investigations. Scientific evidence is often used in criminal investigations to establish facts, identify suspects, and link individuals to crime scenes. Forensic evidence, such as DNA analysis, fingerprint analysis, ballistics, and toxicology, can provide valuable information to investigators and help solve crimes. Number 2. Court proceedings. Scientific evidence is presented in court to support or refute claims made by prosecution or defense. It can include expert testimony, laboratory reports, and forensic analysis results. Scientific evidence can be used to establish the guilt or innocence of a defendant, provide motive or intent, or challenge the credibility of witnesses. 3. Civil litigation. Scientific evidence is also used in civil litigation cases, such as personal injury claims, product liability cases, and environmental disputes. Expert witnesses may provide scientific analysis and interpretation to support or challenge claims made by the parties involved. Number 4. Medical and health research. Scientific evidence is essential in medical and health research to establish the safety and efficacy of treatments, develop new drugs, and understand disease mechanisms. Clinical trials, laboratory experiments, and epidemiological studies generate scientific evidence that informs medical practices and healthcare policies. Number 5. Environmental studies. Scientific evidence is used to assess environmental impacts, monitor pollution levels, and evaluate the effectiveness of conservation efforts. Environmental scientists rely on data from field studies, remote sensing, and laboratory analysis to understand ecosystems, climate change, and the effects of human activities on the environment. Number 6. Engineering and technology. Scientific evidence is used in engineering and technology to ensure the safety and reliability of structures, products, and systems. Engineers rely on scientific principles, testing methods, and simulations to design and evaluate the performance of bridges, buildings, vehicles, and electronic devices. Scientific evidence provides a foundation of knowledge and objective information that is crucial in decision-making, problem-solving, and advancing various fields of study.
Physical evidence refers to any tangible object or material that is relevant to a crime or an investigation. It can provide valuable information and help establish facts in case. Here are some common types of physical evidence. Number 1. DNA evidence. DNA evidence is one of the most powerful types of physical evidence in a criminal investigation. It can be found in a blood, saliva, hair, skin, cells, or the biological materials. DNA analysis can help identify individuals, link suspect to crime scene, and establish relationship between individuals. Number 2. Fingerprints. Fingerprints are unique to each individual and can be found on a various surface such as glass, metal, or paper. Fingerprints left at a crime scene can be compared to a suspect fingerprints to establish their presence at the scene. Number 3. Footwear and tire impression. Footwear and tire impression can provide valuable evidence in linking suspect to a crime scene impression. Left in soil, mud, or other surfaces can be compared to known footwear or tire patterns to identify the source. Number 4. Tool marks. Tool marks are impression or patterns left on a surface by tools or instrument. They can help identify the type of tool used in a crime such as screwdriver, crowbar, or knife. Tool mark analysis can provide evidence linking a suspect to a specific tool or object. Number 5. Firearms and ballistic evidence. Firearms and ballistic evidence includes firearms, ammunition, spent casing, and bullets. Forensics analysis of firearms and ballistics can help determine the type of weapon, use a match bullets to specific firearms, and establish the trajectory of bullets. Number 6. Documents. Documents such as handwritten notes, forged signature, or altered records can be important physical evidence. In cases involving forgery or identity theft, forensic document examination can analyze handwriting, ink, paper, and other characteristics to determine authenticity or identify the author. Number 7. Trans evidence refers to the small, often microscopic, materials found at the crime scene, such as fibers, hair, glass fragments, paint, chips, or soil particles. Analysis of trace evidence can link suspect or object to a specific location or connect individual to each other. 8. Impression and tool marks. Impression and tool mark left at a crime scene can provide valuable evidence. This can include shoe prints, tire tracks, bite marks, or marks left by tools comparison. And analysis of this impression can help identify suspect or provide information about the crime. These are just a few examples of evidence types commonly encountered in forensic investigation. Each type of evidence requires specialized techniques and analysis to extract valuable information and support investigative efforts.
The retrieval procedure for criminal investigations involves the systematic collection, preservation, and documentation of physical evidence at the crime scene. Here are the general steps involved the retrieval procedure. First, secure the crime scene. The first step is to secure the crime scene to prevent contamination or tampering of evidence. Law enforcement personnel establish a perimeter, restrict access to authorized personnel only, and document the initial condition of the scene. Number 2. Assess and document the scene. Investigators assess the scene to determine its boundaries and identify potential evidence. They take photographs and make detailed sketches or diagrams of the crime scene, noting the location of items, bloodstains, or any other relevant details. Number 3. Conduct a walkthrough. Investigators conduct a thorough walkthrough of the crime scene to identify and document potential evidence. They systematically search for physical evidence, ensuring they cover the entire area, including floors, walls, ceilings, furniture, and other surfaces. Number 4. Identify and collect evidence. Investigators identify and collect physical evidence that is relevant to the case. This can include DNA samples, fingerprints, weapons, clothing, documents, or any other items that may provide information about the crime or the individuals involved. Each item is carefully packaged, labeled, and sealed and maintain its integrity. Number 5. Preserve and document to the chain of custody. The chain of custody refers to the documentation and tracking of evidence from the moment it is collected until it is presented in court. Investigators ensure that the evidence is properly labeled, sealed, and documented to maintain its integrity and admissibility in court. Number 6. Document observations and interviews. Investigators document the observations, including any relevant details about the crime scene, witness statements, or suspect descriptions. These observations and interviews can provide valuable information for the investigation and subsequent analysis of the evidence. Number 7. Submit evidence for analysis. Once the evidence is collected and documented, it is submitted to the appropriate forensic laboratory for analysis. Forensic experts analyze the evidence using specialized techniques and instruments to extract relevant information. Number 8. Follow legal procedures. Investigators follow legal procedures when handling and presenting evidence. They ensure that all evidence is properly documented, stored, and transported according to legal requirements and guidelines. It is important to note that the retrieval procedure may vary depending on the nature of the crime, the jurisdiction, and the specific protocols followed by law enforcement agencies. The goal is to ensure the proper collection, preservation, and documentation of physical evidence to support the investigation and subsequent legal proceedings.